of your time and not reached the conclusions yet, then I will give you a sign within 2 or 3 minutes before to let you know. Perfect. Then the stage is yours. Hey.
I hope I know what to do here. All right. I hope you can hear me. That's good. So, hi. My name is Timo Ornio. I work for the National Land Survey of Finland. And the topic of my presentation is taking full advantage of your SDI with Oskari. Basically, it's divided in 2 parts. First, I'll give a short overview about the software for those who don't, or for those who are not familiar with it, and then I will tell you about this year's development, so what we're doing this year with the software. And let's get started. I hope this thing works. I can use also the arrow. So this is in short, or in a textual form, what we do with Oskari. So it's an open source software, first of all, and what you can do with it is basically two things, or you can divide it into 2. You can set up your geoportal, and that's how it all started in 2008. So the Finnish national geoportal is set up with Oskari, and since then we have developed it, so almost 10 years in development. 2011 we open sourced the project, and it has grown a lot, obviously, after that, since we have gotten a lot of new users. And so in addition to a geoportal, you can also use that geoportal to create embedded maps or publish maps and embed them on your own websites or e-government services or what have you. And also we have some tools to support decision making and data analysis. And the main point, or the SDI viewpoint here, is that the emphasis of Oskari is very strongly on the spatial data infrastructures. So what we use are always the standard interfaces, OGC ones, which I'm sure you are all familiar with since you're here. So Inspire SDI and ELF SDI, etc. And Oskari is also multilingual, so we have full coverage for English, Finnish, and Swedish. And in addition to that, we have partial coverage for some 15 other languages done in the ELF project. So quite a lot of localizations has been done also. Oskari.org is the webpage where you can find all the relevant information. The links will be at the end of this presentation as well. Moving on. This slide is kind of the same thing in a more visual form. So the basic idea is that you have your datasets on your databases, and you put your interfaces on top of them, and mostly Inspire data, or mostly spatial data, but we also support statistical data. I'll tell a bit more about that later on. And well, this slide is a bit old. Also, statistical data can be offered through standardized interfaces nowadays. And the point is that all of these interfaces connect to Oskari, so we are not storing the data within the instance itself, but we connect to the interfaces and utilize them directly, so that you always have your most up-to-date data at your disposal. Then you can create these embedded maps, as I said, and you can put them on your website like this. This is the tool that you use to create those maps, so the kind of map publishing tool, and then they are offered through the instance as software as a service as a browser-based application. And we support also, of course, mobile devices since a long time already. And furthermore, which is kind of not the topic of this presentation, we have something called RPCs, remote procedure calls, that you can use to kind of communicate between the web page and the map component that you have embedded. So you can, for example, if you have an e-government service, you can provide a different UI for the user, and then you can use that information that the user gives you and control the map, move the map, zoom it, draw some features on the map, or whatever. You can let the user draw something and then get back that information to your own system or service. So that's kind of in a nutshell what Oskari is. And few words about Oskari community. As I said, we open sourced the project in 2011, and since then we have grown a quite large community. We started out with just couple public sector organizations, which are listed here. Some of the logos are in Finnish, I'm sorry about that. Not all of them are available in English, unfortunately. So these were one of the first ones to join, and we also have a lot of companies in the community. In Finland we call it network, but one thing I should mention now is that we are applying for OSGeo membership, and we are currently in the incubation process. So if we are lucky, we should complete that in some time, probably during this year. So next year we should be an kind of fully accepted OSGeo project, like many other well-known projects are. And one more thing I shouldn't forget to mention about the community. Last year we took part in the European Commission's Sharing and Reuse contest, and we got second in the cross-border category. So that was a kind of sign of appreciation, and that we have really been able to provide a reusable product for other ones to use as well. So Oskari is also not used only in the Finnish geoportal, but also, for example, in Iceland, in the ELF project, or now ELS, and in addition to that, Arctic SDI. Some of you might know those projects or recognize them. All right, moving on to the development part. So what we are doing this year, this is not a comprehensive list. It's just 4 examples. We are doing a lot more in addition to what I'm going to talk about here, but time is limited, etc. So I have kind of the biggest improvements on display here. What we're about to do this year, or what we have already done, and what we are doing for the rest of the year. My favorite child, so to say, is the new thematic maps tool. We used to have a nice thematic maps tool, but it only connected to one interface or one type of interface. Now we have a wider selection, or actually you can build your own adapter and you can pretty much connect it to any interface that provides, for example, statistical data, and you can join it with the geographical data, and then you can make a thematic map out of it, and a lot more, obviously. This is a gradual.symbol map, and you can make choropleth maps, and by the end of this year you should also be able to have time series, animations, different kinds of charts, histograms, and of course you're able to publish all of this and embed it on your website. This is actually a screenshot from an embedded map, so this is how it would look like on your website then. And fully interactive, of course, when you hover your mouse on the map. And next we have support for web coverage service. This is a mock-up picture. It's not a real picture since we haven't implemented it yet, and we're kind of only now looking into the use cases and what to really do with web coverage service or services. But this is just one example what we could do and what we kind of will start off with. So a height model, or you can draw your own route, and then you can see how it looks as from the digital elevation model point of view. I would like to talk with Dr. Baumann about the kind of possible use cases here, but I'm afraid I will not have time since I have to leave in about 5 minutes this building. But maybe another time. Third thing that we're doing this year, and this is a screenshot from the Arctic SDI geoportal with a nice projection. VMS or web map services with time dimension. We already have support for the services that support time scale as well, but we will improve it. I was just looking at the kind of concept what we will add to this. So now you can see there is a play button, so it will animate over the time available from the service that you're using. And what we will add to this is you can pick the playback speed and you can pick the kind of the unit if you want to use days or years or seconds or whatever you have. From the services, and you can also skip, and we will do a lot of kind of new functionality to this already available tool. And this is, of course, everything I'm showing here is something that you can also publish and embed on your web page. So that's always the kind of viewpoint how we do things. So the fourth thing is support for projections, kind of changing on the fly. This is something we also started already and already have, and this is an actual screenshot. So this is from the showcase application for the ELF project. You can change the projection on the fly, but it has its limitations currently. Currently you can only kind of have one default projection, and all the features are then supported in that one. And then when you change, you can only kind of view maps and publish maps, but you can't really use the tools, or you can't import data into other projections or coordinate systems. And we are going to improve this this year quite a lot, and that will be coming to the Arctic SDI project, or it's funded via the Arctic SDI project, and should be available by the end of this year. As I said, this is only a short list what we are doing. We are doing a lot more, and also other organizations are doing a lot since they are developing Oskari for their own needs, and they will be integrated into the Oskari core by us then when they are published. So that would be all from me. Here you have all the nice links: Twitter handle, Oskari.org, GitHub page. Thank you.
Thank you. Are there questions from the audience? So that would put me in the unpleasant role to come up with a question, which is very difficult. What I was actually wondering, where is Oskari, the name, coming from?
That's the most common or second most common question we get. Yeah. It's coming from a OS, open source, obviously. And Kari is short from karttaikkuna, which is Finnish and stands for map window. Okay. So open source map window. That's how it all comes together.
Okay. Thank you very much.
Thank you.
Then I hope you still get your train.
I should.
Yes. Then thank you very much. One more applause. And Peter, the floor is yours.
Thank you. Going to the blue floor and exploring the PC here. I believe that is a good thing.
Good luck.
Yo, that looks somehow familiar. Fantastic. Okay, fine. So he's left already. Have a safe trip to the airport and with a plane. So I have the honor and pleasure to be next year in the row, and a few keywords already have been mentioned anyway, so I can build on that. And the central keyword will be the data cubes. to show how these data cubes can be utilized effectively, and by the way, what are they good for? Why do we need them after all? I would say it's centrally a matter of service quality. Regardless of the technical aspects behind, it is just simpler for users. Why that? We had that earlier on. People don't like so much these tons of files with cumbersome file names and semantics in the file names and whatnot. Since Google Maps has started doing seamless maps on a large scale over the web, we enjoy having not a million of files, but one single object. What now if we do that in more dimensions? We have one seamless map, and we could have one seamless cube that extends into the time axis as a third dimension. Or elevation. We could have four-dimensional data cubes, and this is where we get into this cubicle structure. Why is that good? Again, because users see one object instead of a million objects where they have to make sense themselves. And by the way, now we can start operating on them. We can slice them. Of course, we can extract a particular time slice, but we also can go through vertically and have time series analysis, have elevation analysis, and we can combine all of that on one object. So my thesis is that data cubes simply are the next step in having more data, a better user experience, and by the way, getting towards having data analysis ready. And if you want to see some large example, we have the Earth Survey initiative that unites 3 continents over altogether 6 years. Currently, we are in year 5. And sorry, the goal is to establish analytics on data cubes, on 3-dimensional image time series data cubes and 4-dimensional weather data cubes. The client-server interfaces are rigorously standards, in particular the web coverage service. And on server side, we find genuinely European technology, rasdaman. On client side, we like to use NASA Whirlwind from the US. And I like to have some glass. Cheers.
Do we have a glass?
Okay. So
okay,
what do we find? We have Mio, an Italian company, an SME, that hosts Landsat and Sentinel data and is hosting currently more than 700 terabyte already and working themselves towards and across the petabyte frontier. PML is doing, Plymouth Marine Laboratory is doing ocean color analysis. National Computational Infrastructure Australia is providing a Landsat data cube, and the European Center for Medium-Range Weather Forecast, well, their climate data. And this is particularly interesting because we are working with them to unleash their archive, which has more than 170 petabyte of data. And we want to get these online. Okay, so that looks like the things that we see from a browser. By the way, the Australians are talking about a data cube, which is very fruitful. It helps promote the concept. And the largest 3-dimensional data cube that you find in Australia is the one run by rasdaman, because all I've seen so far from the Australian data cube was 2-dimensional. And you always will realize the time series here in these screenshots, where you have the slider, the time slider, and so you can derive specific products on the fly. ECMWF does river discharge and others. And with our German remote sensing data center, we have done a data cube of 10,000 images on AVHRR data, for example. Same thing as before. You can cut out slices. You can drill through to time series analysis. But please look at the bottom left, what year that was. So we are doing that now for quite some time. And so the technology actually is quite established now. And that is the next thing to talk about. First, to resolve this fancy name, rasdaman, standing for Raster Data Manager. I must admit we are coming from a database direction. We like query languages because on the one hand, a query language is flexible and it allows any query anytime. On the other hand, it allows, for optimization on the server side. So we have extended SQL with multidimensional arrays, with data cubes, have implemented that. And actually, you can just as well do that with brain images. We also have done it with cosmological simulation. It's always the same principle. That way, rastaman has become the blueprint, actually, for DataCube standards, like the extension of SQL of the standard with multidimensional arrays, and also with a coverage service suite. And so, no surprise, before we issue the specifications, where I happen to be editor, we implement that. And so OGC and Inspire reference implementation is rastaman. The architecture is like this. The central workhorse is the rastaman server in the middle. It's multi-parallel without a single point of failure. You can store data in a database like PostgreSQL in the file system, which we have implemented as a storage manager. It's about 2 times faster. And you can use any external archive, so you do not need to copy the data. The query processing is always the same. That is domain agnostic. And on top of that, we have the geoservices, which know about coordinate systems, about space and time, and about regular and irregular grids. The processing relies on techniques that analyze each incoming query individually, so not as fixed as map reduce, so first map, then reduce. For example, in this case, we might find out the yellow part of the query we can process immediately. The orange part, we send it to a buddy in the cloud to do the processing for us, because this one has the data. With the same principle, we can send queries to another data center for processing. And if you want to see that live, come to our rastaman booth. I will show it to you. And you can even send it to a moving target, like on a satellite. This is what we are doing currently in a project. The principle has been extended so as to to split the query over more than 1,000 cloud nodes. So that is one of our internal mechanisms to make query processing fast. Okay, and then you can do fancy stuff like terrain draping. I don't want to discuss the query here. This is according to the OGC WCPS standard. You can do terrain draping. You can emulate a web map service. This image top right was generated from a query like the one you see here, and you get just one single image. So not 4 images to be overlaid in the client, but 1 image. So it also can be faster during transmission. Anyway, the query language is not what you want to see. It's a pity, and we are sad about that, as we develop the query languages, but you don't want to see them. You want to use your clients, the well-known ones. And so we work hard to let users remain in their comfort zone of their well-known tools. So for map navigation, you access the DataCube via open layers, say. Virtual globe, okay, Whirlwind or Cesium. WebGIS, use QGIS or so. Analysis, use Python, and do your analytics in NumPy directly. The magic is that we have these standards as a client-server interface, and so actually any client tool that supports that standard can interface readily. And the query language and the request language just remains some interface issue between client and server, which is hidden internally. So, altogether, DataCubes. I try to explain what the concept means and why that is useful towards more user-friendliness and towards better service quality. That means going towards analysis-ready data that can be utilized immediately without download, processing, etc. And we have standards in place, fortunately. Coverages as a data standard and web coverage service as a service model. And by the way, in OGC we have conformance tests which allow to test down to single pixel level whether a tool fulfills the specification or not. So this really establishes interoperability. We have started doing that about 20 years ago when everybody said you are crazy. And if you want to look at it, rastaman.org offers the source code and lots of tutorials. And as I said, this is something that is being used already. And so maybe that is something that could be considered when it comes to offering that kind of data. And with that, I would like to, I hope I'm staying in time, I'm not sure.
Yes,
but I would like to stop here, and maybe there is some discussion on it. I would appreciate that. Thank you for your attention.
Thank you very much. And are there questions from the audience? No questions? And I have to admit that even for me it was difficult to come up with some intelligent questions, so I would rather like to skip that part, and shame on me as a chair. If there are no more questions from the audience.
Once again, if you want to see more about it, then come to our booth, and I'll be happy to give you a live demo. And just before rushing away, it's not always Hadoop that is the best solution. Just let me mention that.
Yes.
Okay. So
thank you
I'm
very much.
making way. Does all the for work? Oh, okay.
Thanks again. So our next speaker would be Thorsten. And I have to say that I exploit your booth very much, because I supply myself with this kind of gimmicks, which make the presentations feel like if I would be in a cinema.
Okay. That was my idea.
It was a fantastic idea. Now
And
I
we
would also
also-
like to hear what this booth was actually about.
Yeah. And we had some apples, fruits
Well,
as
this
well.
is all vegetables and fruits. No.
Okay. Oh, French. Oh, yeah.
It's down there, this button.
No, I found the shortcut.
Voila.
Okay. Okie dokie, let's go. Hello, my name is Thorsten Friebe from Latlon, and I will talk about a fast Inspire download service based on Degree Enterprise technology. And before I start, I really like to know who of you is actually using Degree. Because if you don't use Degree, it may be a little bit boring for you. Okay, at least one person, two,
Well,
three,
one was using
four.
Degree.
Come on, let's give it a 5 and a 6. Perfect. Okay, for the others, I hope you will still find something new and interesting. It will be a little bit technical.
Don't enter into the details which kind of user level we have.
Easy. Okay, first about me. If you don't know me, I'm working at Latlon, a small company. It was spin-off from the University of Bonn, founded more than 15 years ago. I joined the team recently, 5 years ago, but I started the project of Degree. At the time it was called Jago in 1999, and I came back to finish some work. I'm also a member of the Technical Management Committee. That's a small group of people who do volunteer work for the OSGeo project Degree. And there I'm in charge of to organize the meetings for the technician guys. Before I dive into the technical stuff of my talk, I would really like to give you a very, very short intro about Degree, because it's still important to mention what is Degree community about. Degree is a reference implementation for a lot of very important OSGeo standards. Reference implementation, what does it mean? We comply to the specification, we fulfill the executable test suites, and the software is open source. So you can have a look how we implemented the OGC standards, and you can learn from it. These standards, most of them, at least you maybe come across along when you're working with Inspire. Yeah? WFS 2.0 and GML 3.2.1. Degree is a reference implementation of that. Further numbers about Degree. I think I had the impression during the conference that I should put that slide back into the presentation, which is from the OSGeo conference, the Phosphor-G last year in Bonn. The Degree project is on GitHub. That's our main address. Please make a note, take a picture. If you have questions, if you want to know something about degree, that's our main entrance page. For open source guys, some numbers, we have quite a lot of forks, increased from last year again by 2, so 68 forks, so people are actually using it, try to implement, play around with the code, which is actually, that's great, we really like that. 40 persons do love the source code or the software itself, so they are putting stars on it. 22 people do watch the project actually, and we have 20 active contributions or committers as we call it. Some more numbers about degree. There's a release candidate available, and that release candidate has, compared to the previous version, 30 new features. We added 98 enhancements, and we fixed 156 bugs since then. We can talk about software quality, but I think as a number, it's quite impressive what has been done during the last year. But now talking about the topic about setting up an inspired download service with Degree and Degree Enterprise. In a common setup, the source data is present in a relational database. And that relational data is transformed for Inspire into something like GML. The GML is used at the base technology, a standard extended by the Inspire schemas for topics like protected sites and others. And that transformation is quite heavy. It requires tools, very sophisticated tools, which are capable of doing a transformation from a relational data model into a more object-oriented model like GML, because GML is a kind of an object-oriented model where geographic data can be stored in. So you do have an ETL tool at place. It may be Hail, it may be FME or other software you're using, and you have to manage that. That's the first time you do a transformation. Then, for example, if you do use one of the products I just named, you may use the WFST, the insert action of the Degree web service to insert that data into the Degree web service. And when you're doing that, maybe you are aware of that, the data is again transformed back into a relational model. So first we were happy to transform the data from relational model into the GML data, and now we are doing it again. So there was heavy lifting before, and then again some work done on the WFST side. There, the object model is mapped back to a relational model. And when you then try to access the data with a WFS get feature, for example, the data from your relational database is again transformed into the GML object model to comply to the OSGeo and to the OGC standard of GML 3.21, and of course to the Inspire guidelines, where we have to deliver harmonized data in GML 3.2.1. So there's again some heavy work done. On the Degree side, it requires hardware resources, CPU and memory. And when you're actually using the data and you're accessing the data and you're using full-blown filter expressions on the WFS interface, it requires again a lot of hardware resources in the Degree WFS. So there are at least 3 transformations in that scenario. Maybe you're aware that besides the relational mapping, how we call it, there's a blob mapping. What is the difference between the two, which the community edition of Degree provided since 3.0 from the early beginning? The main difference is in the relational model, the GML structure is mapped to a relational model. So you will have depends on the schema, when you use protected sites, it's okay. When you go to transport networks, it makes a headache for a developer, really. It's quite complex. Because with every domain class, a table is derived and it's mapped to the database. As an IT guy, we learned from Ted Newert, I think more than 10 years ago, that there's an object relational mismatch which doesn't fit very well, and we try to come around of it. He called it the Vietnam of computer science. He actually did, and he made a really nice talk about it. Just search the internet for it. The GML object then later, when an instance is mapped to the database, is mapped to the relational model. So it's distributed in the database in entities, in columns, and data types, very fine-grained. The blob mode was the approach to optimize that in a way that the GML object is stored as it is in the database in the blob. That's not smart, but it's good, because we solved one problem. When data, which is valid at the time when you import it into the WFS over the WFS-T interface is valid, then you want to stay that data valid, schema valid, compliant to a specific XSD. But maybe with the first approach may break that. The second approach, the blob mode, will keep the data as is. So that's the big advantage. If you ask, so how can I, by the way, create that? I think, and I consider this as a very important slide which I added, because it was mentioned by Dirk Thalheim yesterday when he talked about using degree for transport networks. There's a command line tool where you can actually create those configuration files in the database mapping. It's a command line tool you can use, you can download, you just fire it up, give a pass to the Inspire schema file, and it generates the data and the configuration for the degree. What will be the outcome of that generated XML configuration? Here's the example with the typical relational model. You see it quite complex. It's only a half of it for protected sites. As you can see, or maybe you can see it, it's about protected site. That configuration file has a length of roughly 800 lines of code. So it's XML data, yeah? And the data which is stored in the database, as you can see, is split up over multiple tables and multiple comments. And it's quite complex. And you can imagine that a SQL statement, an insert, or a select is not performing very well when it goes to big data. Like, not big data, I say something about a gigabyte of data is already making a headache for the database engine. So rethink that again with the blob mode, so we can eliminate the transformation to the initial transformation which is needed to harmonize the data. That only the TL2 is a lot of work doing to transform the data into the harmonized schema and the data structure of GML. And then the WFST is doing a little bit less work, yeah, because it can take the GML object and stores the stream directly in the database, and a single GML object is stored as a blob in the database. So we can definitely reduce the heavy lifting for degree WFST. For the output, there's some negative aspects about it. If you use the blob mode, if you already used it, you may already experience it. You have some limit functionalities, or the functionalities of degree, the WFS are a little bit limited. But later to that. First, how does it look like? The configuration of degree is quite simple. It's easy to grasp what it's about. Okay, it's about protected sites. It says blob mapping. That's it. It's a one-liner. I can do that even without reading the documentation. And storing the data in the database, okay, it's a little bit ugly maybe because the highlighted yellow areas shows that the XML is stored as it is in the database. Without really thinking about it, what are the advantages and disadvantages? Again, the intention was that we keep the GML data as it is. So if data is valid, it has to stay valid, even if it's stored in the database, even if it's part of a response of the WFS. But as I said, there's some drawbacks of that solution. The queries you can use with filter expressions, which are translated into database queries for the relational model, which are performant. And you can do a very fine-grained filtering on objects. This is not possible with blob mode because everything needs to be processed in memory. And therefore, if your scenario is that you want to have a high-performant WFS with doing a lot of filtering on the WFS interface, then the blob mode is not your friend. And you have to stay with a relational model. So the question, is why transforming GML objects, by the way, from objects to a relational model and to store it in a relational database engine? Well, why do such a lot of heavy lifting? Why not just taking the GML as it is and use an XML database to keep the data really as it is and to leverage and foster the advantage of using an XML database to work directly on the full XML to have the advantages of both solutions. And that's the idea about a new feature store for degree, which we will implement based on a technology I learned last year at the Inspire conference from people from Interactive Instruments. They have used it in their project to use an XML database which is capable to store XML data, and there are already modules, libraries available which allow also to act on GML data structures. So with all the functionality we need as geo guys to act to make special queries on it. So the heavy lifting still up front, no solution for that. It's up to the others to find a solution for that to make it easier. But if you do have GML data, it's compliant after the transformation. The feature store using an XML database will keep the data as it is, store it in the data, and will respond and take that for the response for the WFS get feature response as well. So definitely far less activity while inserting the data and far less activity on hardware resources when providing WFS responses. So conclusion. When using an XML-based approach, even for the storage, less data errors are introduced during the transformation. The relational model, just play around with the Inspire application schemas, transport networks to get a compliant and a schema-compliant response requires brain work. It's not solved by the software as well. The GML data can be stored as is, so if it's valid, it stays valid. It's not handled by degree, it's not broken down and put together again. Less resources are needed, less time. An import is quite faster, a response can be provided faster. But what is the problem about it, or what is my question, is the user community of Inspire, or in general of geospatial data, willing to adopt XML databases? Because that's a technology quite new. Only a few institutions or projects already use that kind of technology. And if you do have already experience, I'm really interesting to know if that could be an approach for you as well, to keep and store your geographical data in an XML database. And if you like to know more about the project, XSpace and the extension library to handle GML data, there's a link I really can recommend it to surf to that website. We are planning to do an implementation based on the product version of the Degree Community Project, Degree Enterprise, and we do plan that for the release for next year. Currently, we have recently released 2017.1 release, which is general availability. And if you're interested for a demo or talk to us about our product solution of Degree and the upcoming features with the XML feature store, surf the website or just come across the booth. We still have some of those nice little suites, and thank you, Christian. So,
thank you very much. So it wasn't not so technical as I was afraid of when you mentioned it. Are there questions from the audience? Yeah, we have a question.
oh, good.
Fantastic. Dominique.
Yes, there is this general issue with Inspire data that there are no GIS client to exploit them. So should these GIS vendors use this kind of technology of XML database to develop clients able to really exploit the Inspire GML data?
Yeah, that's really an interesting question. Recently, talking to the OSGeo colleagues from GDAL and QGIS, and maybe some of you are aware what they are currently doing, it really may be interesting to have a client using that technology so that we do not lose data quality, yeah, and data maybe as well, because during transformation you can lose the quality, maybe also data. It would be interesting to have a client, because we know that for Degree download service, a lot of people said, well, we don't need it because we don't have a client to use the data, to query with filter expressions against it. So we are happy with a atom feed. But I think now time's moving and clients are improving. We have seen nice approaches. We will see. And again, we are interested to share and to learn from others the experience, if that could be a technology for clients as well.
Yeah, maybe to add to this, you're absolutely right. There's recently ongoing development on the open source side, on the library GDAL or GR, and there has been further development made to import complex feature GML. And to build, well, it's a kind of reverse approach, because to build a relational database which you then easily can consume in a desktop GIS client based on the schemas of the complex feature GML. So this is, well, of course it's not mainstream yet. It was developed last year. It's now available under QGIS, under the Windows version. It's, since a while it was developed under Linux originally. So, but we hope that those clients are coming, and GDAL might also be taken up by other products like S3, FME, to be included in their product as well. Are there other questions? Yes.
Thank you, Thorsten, for the presentation. So a couple of years ago on the Bolsena code sprint, I already discussed with Andreas about this challenge between blob store and vector store and the inability of the blob store to do queries. And I just saw a presentation from Thorsten Reitz where he indicates that he used a layer of Solar on top of the blob store to manage the queries. Is that something that you're investigating also?
That's correct. There was a kind of a technology study developed at that time, but that has been dropped since then. There was no further activity. I haven't said that I'm honestly, I have to admit it, or committed now, I'm an XML hater. Yeah,
Ooh.
I really joined the club years ago that I decided I really hate XML. And I even more hate complex schemas. No, really, they make a headache. And the idea was to get really away from that mismatch between XML, GML, object-oriented approach, which we do have for the data, and then to bring it into a relational model. The approach with the search index is, I would say, only part of it. Yeah? The goal is also was with degree that if you use the relational model, it might that you lose the data quality in terms that during the transformation really data get lost. Yeah? And to get rid of that, we were really looking for a total new approach besides all relational databases. Yeah? It may be early, it's an experimental approach, yeah? But it would be, again, a step where maybe other clients, yeah, as you ask, could access the data as well. Now, with all the other technologies, you only try to optimize it in a way, but you're not really solving the problem. And I don't know if that approach is really solving the problem, but it would be a different approach where different clients, even servers can access the data. Yeah? Because, may I ask, give a further reply to that the blob mode, a lot of users rejected that technology or that kind of approach because they said, well, I cannot reuse the data. I can only use the data with degree. I don't have a client to access it. With a relational model, a lot of users were quite happy because it was at least possible to use database technologies and QGIS or other GIS software to access the data, to write back to the data, and really to maintain it. And even it's easier to set up a WMS based on degree and the relational model. So that was, again, also part of that idea to come up with a new approach.
So then thank you very much again.
Thank you.
And our next speaker is Christian Schwarze. And yeah, the title was really difficult to penetrate for me or to get a picture what that might be, what you're talking about. So I'm really curious.
Thank you.
One of those famous freeliners.
No. The PDF file is missing, or
Right click, Ouvrir avec. Maybe a French speaking.
Ouvrir.
No, it's still it. I guess you want to have this open with equivalent. I see.
A full screen?
Oh.
No.
FF.
FF.
Full screen would be the, yeah.
This one?
Have you clicked?
Oben noch rechts in den Rahmen
This one? No.
Yes.
Really?
Click.
Cool. No, huh? The next slide is page down, or but
Yes,
it's
I guess
oh,
so.
that's not very nice, or
Oh,
there's no Acrobat reader or something like that.
well, there should be.
So.
Dum, 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 dum.
On Wednesday.
There was Aufgabe.
Ah, okay, that's perfect.
This was what I tried to explain.
Thank you. Sorry. Yeah, thank you and good afternoon. Yes, accept it.
Except without reading.
That's cool. We? No?
Continue. Just close. Okay. Then maximize. Yeah.
So thank you so much and good afternoon. My name is Christian Schwarze from a Codematics company in Jena. And I want to talk a little bit about data preprocessing in the field of elevation datasets along national or national watercourses. And I had a very similar slide on Wednesday because the initiator of the project was the same. It was the ITZ Bund in Ilmenau, which is the IT service provider for mainly federal agencies in Germany, and is responsible for the hosting and operation of IT administrative processes and also software development. And on the right side, there's the company I'm working for, and we are focusing on geospatial applications, GIS programming, and so forth. A few words about a web application called 3D Datenarchiv. It's a web or it's an intranet application, especially for the BFG. In German, you say Bundesanstalt für Gewässerkunde, and you can translate it to German Federal Institute of Hydrology. And the application 3D Datenarchiv is the main application for central archiving, searching, and providing all these terrain and riverbed data along these waterways. And not only waterways, also at the coastal regions. And which kind of data types are stored in this 3D Datenarchiv? Well, you have data types like profiles, either along the watercourse or across the watercourse. You have also break lines stored inside. A lot of measurement data from surveying flights or something like that, bearing data, grid points, irregular network data, and so forth. The question is, these types are not necessarily the data types identified by Inspire for sure. And therefore, there was a preliminary review at the beginning to identify which data in the 3D Datenarchiv is relevant for Inspire. And we were looking for software approaches and geodata transformation concepts to meet the requirements of Inspire, and especially for the data theme of the elevation of Annex 2. And also, of course, to find out which methods we can use to provide the processed data in form of view or download services. So the basic situation was that we got a lot of data as XYZ data. It was about 220 gigabyte files, ASCII formatted. So I told you XYZ, very simple text file format. And the first thing we did together with the BFG to identify which data types in the Datenarchiv are relevant for Inspire, and we can serve with the data stored there. So that was the elevation grid coverage Inspire and the Inspire control line feature type. And what we get first was a consolidated and separately provided databases of these elevation data. These are very high resolution, a lot of data with a high resolution, about 1 meter or 1.5 meter or something like that, for a total of, I think, 19 federal waterway sections. And in order to fulfill the requirements by Inspire regarding the elevation encoding and so forth, there is a special pre-processing needed. So what are the main goals? Very briefly, well, we want to develop a workflow which is, of course, configurable and nearly automated and performant. Therefore, we are using, in this case, Python STATL, and later the QGIS processing framework as an extension or as a post-processing step. And with this workflow developed, we also want to output more popular GIS formats than this XYZ format, for example, geotiffs and other formats, in order to enhance the further processing with these geotiffs in respect to other products or services like elevation models, contour lines, or hill shape maps. So, as I told you, we were using STATL in this context. So STATL is a typical extract, transform, load approach. It's open source software, it's a Python software. And the letters ST means nothing else than streaming ETL. So that is a good approach to make your transformations quite fast, in my point of view. And so the main concept is to transform your data, your mass data, e.g. or for example, GML, based on data packages. So you send packages from one component to another, for example. So this is streaming. So you have no graphical user interface or graphical model builder to set up your model for STATL, but you can do a very good scripting in this STATL environment with Python. You have to script your own single components, and your own single components may base on different tools, for example, OGR, style sheet transformations, and so on. And it's speed optimized, I said it before, so you can expect very fast transformations. This is a very brief overview of this concept. So on the left side you have your input data, for example GML, and right side your output data type, for example a database or something others. And in between you have a couple of components which you write by your own. For example, your own input component for reading the data based on streams, or you have several and own filter components or processing components, and you have, of course, your own output components to transform it to your target. So in our case, that is the arrow at the bottom. You have on the left side our massive elevation data in this XYZ format, and we want to transform it to elevation models, shapefiles, GML, and so forth. This is a brief concept of this workflow. Consists of two jobs. So the job one at the top follows completely these streaming concept. As you can see, we are sending packages from one component to another to create at first real CSV files and later to produce single GeoTIFF files to use it later in another job, that is the job 2 at the bottom or on the left side, where we create the final map products like colored hill shades or contour lines and other resulting maps. So I said it. Yeah, I don't want to go into detail, but just want to show you how to configure your workflows. So on the left side, there's a screenshot of some configuration file. The blue lines are the different components that you script by your own with Python language, for example. And you can parameterize all these components. And the most important line is the first line, where you define the overall process chain by connecting your own Python components. Yeah? So you say what is the first component, where the packages will be sent to another one, and the final component. So this is the first line, and the other lines are just for configuration, the several or the different components. And here's just a line how to start the final transformation step. So you can see it's just a one-liner with some parameterization of your configuration file and so on. And just to give you a very brief overview about such own components which are written in Python. The left side you see a rasterizer, just to implement this step on the top, where we create CSV file, or where we create CSV files, and then typical raster files in the GeoTIFF format. So this is done here on the left side in this screenshot. So we are working with chunks. Yeah, chunks are sending from one component to another, and these components are using, in our case, GDAL or OGR tools. For example, the GDAL rasterize command, and the outputs are individual tiles in GeoTIFF format as input for the other job I mentioned before. So what are the results? As you can see on the left are, for example, hillshade maps, large hillshade maps generated from the tiles produced in this Stedel workflow, contour lines, for example, and also, of course, the digital elevation model for these watercourses or waterways. We provide these results in a WMS using the degree software in the background, and also provide some atom feed to provide single files like contour lines. Some last words about a kind of post-processing steps in case of these contour lines. As you can see on the top, in the red lines are contour lines which are not looking very well because of the edges in the lines, and for visualization purposes, we are doing some optimization to smooth these lines and to eliminate some very small contour lines just for the WMS, just for visualization purposes. And therefore we are using QGIS with this extension named Processing Framework, which includes a lot of algorithms, analysis algorithms. For example, CrustGIS algorithms or Saga algorithms, and we set up some model here just to improve or to make these contour lines much more better. For example, removing small contour lines, smoothing the lines, and adding some additional attributes. For example, the styling in a final WMS service. And this is a screenshot from the final WMS. In this case, it's an digital elevation model along the Mosel River. And you see the contour lines, of course, and on the bottom, a screenshot of the get feature information. I'm looking forward to answer your questions now.
Thank you
Thank
very
you.
much. Other questions from the audience? Dominique, again.
Were the source data coming from the same provider or from different providers?
The source DEM comes, or the source DEM come from the BFG. So it's the original data provider. So you just use these DMs to provide other data sets that are that fits or that fulfills the requirements of Inspire.
And I wondered, maybe you've said it and I've missed it, but who's behind this Statel ETL you were mentioning?
It's an open source software project, so it's not our software. You can download it for free and extend it by your own Python components for the streaming concept.
Yeah. Is there a main developer? Often it is university or a company. Okay, it's you? Or oh, yes.
Yeah, but my question was also the same.
Okay.
How did you find it, actually? This was actually developed by Jus van der Broeke in the Netherlands.
Okay.
And he uses this paid by the Dutch cadastre.
Okay.
Yeah, and so I was surprised to see it here. It's great.
Good. Thank you.
Good that it works for you. So, what I wanted to ask? How'd you find it?
Where Statel comes from? This was the origin.
Yeah, this is the origin. Yeah, and it's still maintained, and happy to see it. Oh, that's what I want to say. It was presented actually on the Paris meetup 2 years ago, where they compared various ETL toolings. There, just presented it there. So maybe I thought that you saw it there, but no.
I never heard of it, I have to admit.
Okay, no problem. Well, have a look at it. It's good software.
Okay. Thank you. Are there more questions? So if not, then thank you very much again.
You're welcome.
And Dominique, is it true that you had 5 presentations this week?
Yes, and it's the last one.
Yes.
So
Let it be the best one.
maybe. All were very good, of course.
Yeah, yes, it sets the standard even higher. The floor is yours.
Yes, I just have to find it.
You need help?
Yes, I am not very gifted without a mouse. It's just to make it. The lack of mouse, that is.
Et voilà.
Maybe. Yes, better.
Dominique Laurent.
Yes.
Et voilà, madame. Okay.
So many thanks. I think, the opposite issue as you with the microphone. So many thanks for those staying for this very last presentation. The title is Extending or Adapting Inspire. The context, it's just to provide the main learnings of a workshop that was about Inspire profiles that took place it was not in September, it was in June. It was a workshop co-organized by InspireCan, that is a knowledge exchange network from Eurogeographics, EuroSDR, and GeoNovum. based on a previous survey from GeoNovum. And it was aiming to share our experience about influence of InSpy on new products, on new projects, with the title, Are we going to extend InSpy or to adapt InSpy? So there were the participants to the workshop. We were around 50. It was mainly about experience at national and European levels in the program. So the legal context, a quick reminder, InSpy is about providing existing data in common data models. There are several ways to achieve it. The first way is to transform your data. In a way, it's what was expected at short term, but it may be also to transform your data model to make it closer to InSpy. Of course, for existing solution, it was expected rather at long-term solution, but I will say for new data, likely it was expected soon because there were only 2 years instead of 7 years for new data. So probably the legislator expected people to make the data specification first close to InSpy 1. So of course, InSpy doesn't require you to change your data production to capture new data. But using these InSpy data models as a basis for national or community extension is encouraged, for instance, in the generic conceptual model. And the general rules for extension, it's don't break any InSpy requirements, and there is a technical solution that is promoted, that is inheritance. The inheritance, it means that you have the InSpy mother feature type or the InSpy parent feature type with all the requirements, and you make a child feature type carrying the extra information. In this way, you are sure you have imported all the InSpy requirements and you are not breaking anything. So the main learnings from the workshop. When does this happen? Of course, the question happens when we make something new. It may be totally a new product, but it may also be redesigning an existing product or an existing production process. It's when there are projects, when there are new standards. So in all these cases, generally, there is a question, should I use InSpy data models? Why do people do this? Why do they take care of InSpy in their data models? I will say it's to make InSpy compliance easier, typically making transformation easier if we just adapt the model, or even not required. If you use the extension, by using the extension, the extended data model is conform to InSpy, so there is no transformation at all required. And this happens mainly at national or at local level. And there is another reason, in a way, InSpy data models have become, I will say, a natural starting point when making something completely new. Mainly for European projects or for new standards. It has also the role of facilitating coordination between stakeholders. We have heard very often, for instance, in federated states, sometimes coming with a European standard is easier than coming from national or local example. There have been lots of experience presented during the workshop. It may happen at various levels. There are experience at global, European, national, local, but the focus was made on European and national. Regarding the InSpy themes, generally it's mainly for vector data. There was, I think, maybe one experience about coverage, but it was the exception. Of course, there were more experience on Annex 1, but Annex 2 and 3 were also represented. InSpy influenced, of course, the data models. In a way, it was the initial topic of the workshop, but we have discovered it also influenced modeling principles. For instance, sometimes some InSpy data types are reused. Maybe not the whole model, but some data types or some code list, and also the general methodology. The methodology of InSpy is really feeding lots of initiative. So how do we do this? Of course, it's what should be the right balance between the need for standardization. In this case, you will go rather to the extension, according to the rules of the generic conceptual model, or maybe you need more specificities, more flexibility, and in this case, you will go rather to the adaptation. So what has the more weight, the inspired pineapple or the various fruits of national or local examples? Why? What is the need for flexibility? What are the criteria to make the balance go one side or another? For flexibility, we can have more data than inspire. So this case, in a way, doesn't help to make decision because it may be managed using either the extension, according to the generic conceptual model rules, or adaptation. So it's not a criteria. But generally, sometimes we have less, but we have more, but sometimes also we have less. And for instance, in Inspire, there are lots of these voidable attributes, or even the feature type in a way, if you don't have them, there is no obligation of new data capture. So there are lots of this voidable stuff that is not going to be filled at national local product. And it was in a way a key reason why many of us choose the adaptation solution. For instance, what was said during the meeting, show what we have without too much noise. Inspire extension rules are too strict about the voidable information that we don't provide. There is no need to keep them in the model at national level. Don't keep in the model what is never filled. What happens also if we have different, for instance, generally we make our models for the production context, whereas Inspire is more about just the delivery of data. So for instance, generally we like to work in our national language and not in English. We work with GIS, and GIS is not yet used to the hierarchic structure of the Inspire model. They like table, so generally we make also flattening of the Inspire data models. Sometimes also we have to merge several application schema in one database. For instance, one hydrographic database may be enough to serve both the physical waters and the hydro network. We don't need two application schema. One is enough. And I will say these are also key reasons to choose the adaptation solution. There are other, I will say, minor reasons, for instance, on modeling issues. There was a funny example about generalization and specialization. With the extension rule of Inspire, you add your local specificities at the last level of the hierarchy. The very small child, and for instance, there was a common property at a very generic level on the object. It was from Sweden, and at the end, it results that one association in the national model results in more than 80 associations in the extended model, because the association had to be made between the children feature type. So, of course, it's not a key reason for choosing adaptation, but it makes the model less readable. However, there are also, on the other side, some benefits for more standardized approach to choose the extension option. Of course, the compliance with Inspire is ensured. If you do this, your data is natively compliant with Inspire. It's also the fact that this Inspire model has a convenient for European use because it's feasible, it's sometimes easy, it's not a bad method, and the voidable concept, in a way, in the European context is adapted. Because it's what happens when you have several countries. Not everyone has the same information, and if you keep only the minimum, you can stay with nothing. So it's nice to adopt really this Inspire model. And at national level, it's also the idea maybe to have a single data set to serve Inspire and national data, to reduce the number of data sets, the number of services. However, I will say that at least during the workshop, the examples from the workshop, the balance was more on the adaptation than on the extension. There were more examples adapting Inspire than purely extending it. if we go in a more technical approach, regarding the modeling approach, I will say there was two main cases. What I have called integration in case of common overlapping content, what really was in the scope of the workshop, but we had also some examples that were more about linking InSpy schema to specific schema. So regarding the integration, there have been 4 methods to make the schema, the data model: the inheritance, the realization, what is called subtype with redefine, and mixing inheritance. The inheritance, we have already talked about it. It's a mechanism for extension, generic conceptual model, InSpy compliant, limited flexibility. The realization, it's typically the mechanism for adaptation. It looks very flexible. In a way, it's free inspiration. It's so flexible that it allows anything. So at the end, there is this arrow between the InSpy model and the national one, but it doesn't say anything about the real matching. So should we document its matching with InSpy and how? I will say this method has been widely used, either explicitly by people making true UML models, but sometimes always in a way implicitly by people working maybe just on the feature catalog or things like this. In a way, it's other kind of realization. There were too much original things. It was subtype with redefine. It seems also a mechanism for adaptation. It was tested but not adopted by Norway in Kartverket, considering that the tools was not mature enough. However, as far as I can see from the illustration, it seems promising if your schema is really close to the InSpy one. For instance, if you are redefining for the language issue and small things, it's probably a good way to have this flexibility and to document the link with InSpy. Another example that was shown only once, it's the mixing inheritance. I think it's a mechanism for extension because the extended schema, in a way, inherits both from the national standard and from InSpy. So it looks both, I will say, flexible and compliant. However, I am wondering how they really deal if there is overlapping content, because in this case, it seems that they are going to store and to capture it twice in the data set. It was not explained with many details, but you can contact Cadastre if you are curious about it. I will even say the name, Ad van Utum. From Cadastre, he was the one presenting the example. And maybe GeoNovum, because they were the ones really making the schema. We had also some experience about linking. Of course, this may be done by classical UML association. I think we have the 2 examples in the room. One was from the EU disaster damage and loss database. It was a new model that about affected element that was in fact associated with the InSpy model on natural hazard zone. So it was just a classical UML association. And there is also the link data mechanism to link, for instance, the InSpy protected site to the designated area of Environmental European Agency. I think there was a presentation during workshop, during this conference about it. And using the InSpy identifier to really make the join, to make the link. So, some conclusions. In a way, it's not just about adapting and extending InSpy, it's also trying to have some good organization of the data, of the knowledge. It's the general objective of this InSpy-based new specification. Of course, methods vary according to the context. The balance between specificities and harmonization, are there already existing solution? What is their weight? Sometimes there are national legal requirements. You cannot move to Inspire very easily because you have the national law pushing in the other direction. And the human factor also, I think, is very important. Is there an Inspire champion in the working group? Are there UML skills? It's also very important. We had discussion also about some extension that are already in the Inspire technical guidelines. And currently, these extensions, they exist just as conceptual models. But the physical models, the GML files, the XSD file, have not yet published by the European Commission. So there are some people, some data providers that are interested in them. But apparently, these extensions are not all of the same quality, and there should be some review before publishing them. There was also discussion about changes in Inspire data specification, because, of course, when you make a new model based on the Inspire one, you discover that there are things in the Inspire data model that are not so convenient and might deserve to be changed. So there was some discussion about the thematic cluster and people pushing requests and having no feedback, something to be improved. I think there have been also presentations during this conference. Another point is also what to do with this extended model, with this adapted model. Should they be at least stored somewhere? For instance, if the model is really very specific, if it's addressing a specific use case or a very local use case, maybe storing it, registering is enough. But sometimes there are these adaptations that are about reference data, and maybe some of this extension will deserve to be added to the Inspire rules themselves. So if you want to know more, the documents are available on Eurogeographic website, and about GeoNovum survey, there are also places where you can find extra documentation. Many thanks.
Merci. There are questions from the audience. Giacomo, I saw you on the picture of the workshop.
Dominique, thank you for your comprehensive presentation, but I would have expected as a conclusion a picture in which you were showing the fruit salad with balance, in which the pineapple was in the middle, in the core. And I guess that you know what I mean, because we learned in this conference more than in the past that pineapple is a key ingredient for many recipes that will be cooked in the future. And so at least guaranteeing that people eating only pineapple should be happy also in any adaptation or extension as much as you may provide.
If I have another opportunity to give this presentation, I will do it. It's a very good idea.
Just one question. Was there a tendency linked to maturity of specific thematic approaches? Sometimes you have the need just to test something, you prefer one or the other method, and if it's got more mature, it's tending towards an extension, or was something coming out of the workshop, just for my interest?
No, we have not discussed about the maturity of the change or things like this. It's more something coming, yes, what should we do about this extension, and maybe assess this national or local extension. They may bring some knowledge. But there was no one saying this should be included in the it was not the purpose of the workshop.
Okay, if there are no more questions, I have a question by myself. You mentioned, well, first of all, we always thought that we are the only ones who are promoting linking. Then I learned from you that there are other approaches, and I would like to get more details about that. So you mentioned that there's linking EU disaster manage, so that there's an example for linking external content to inspire resources as an extending mechanism. So I would, maybe you can share, you can tell me afterwards, or there's a report. There should be a report where I can find the details to that approach, because yeah, it would be really valuable for us.
Yes, there are the presentations, the video recording, the minutes of the meeting, everything is there.
Thanks. Are there any more questions? So the audience is getting, is thinning out. It must be coffee break. And thank you very much again, Dominique, and to all the other presenters. And thanks for joining this last thematic session, and hope to see you in the closing plenary.